So let's learn a little bit more about what's going on behind the scenes when you execute a query. So far, we've been executing queries and seeing results printed out to the screen. In fact, this is a convenient behavior for an interactive shell like the Mongo shell. But what's actually going on when you execute a query, such as db.people.find, and press enter, is that a cursor is being constructed and returned in the shell. The shell is configured to print out cursors by iterating through all of the elements that are retrieved from the cursor and printing out those elements. But you can hold on to a cursor just as you could hold on to any other value in the programming language. Now, in order to avoid printing out the result of this assignment, which is going to be the cursor, I'm going to tack on something completely meaningless, like this null value. At this point, cur is a variable that's holding on to a cursor object. Cursor objects have a variety of methods. For example, the hasNext method returns true so long as there's another document to visit on this cursor, and the next method returns the next document to be visited on this cursor. And so by holding on to cursor objects and manipulating them directly with the hasNext and next methods, you can control the manner in which you step through the sequence of documents. This is not something you tend to do very much from the shell, though you can. Instead, it's a much more common operation to do in a programming language, such as something like Python. You can, for instance, programmatically step through all of the documents to be visited, and that while loop that's close to the bottom of my terminal window is, in effect, the default behavior of the shell when it's printing out a cursor object, except that the shell, by default, batches up the result documents into groups of about 20 so that it doesn't obliterate your terminal by printing infinitely many documents if you have a very large query result. But there are some more methods that you can use to modify the behavior of a cursor. I'll establish a new cursor again by going back up in my history. So long as you haven't actually stepped through the cursor or checked to see if there are any documents left, you can impose limits. For instance, the limit method will instruct the server to return only that many documents for this cursor. Limit also returns the cursor, and so in order to avoid printing things out at this point, I'm going to tack on this mysterious null. At this point, I'm modifying the query that's going to be sent over to the database server. Until I actually retrieve some documents or check to see if there are any documents left on this cursor, no transmission has been made to the database and no query has been executed yet on the database. If I actually do go ahead and start retrieving documents from the database, the query is sent over with the limit as part of the transmission to the database. And so you see, having tacked a limit onto this cursor, I only get 5 documents back from the database, even though there are approximately 8 documents in this collection. There are a couple more methods that you can tack onto cursors. The sort method instructs the database to return documents in an order that's specified by the argument to the sort. For instance, if I want my documents to come back in reverse order by name, that's reverse lexicographical order by name, I can say name:-1 as an argument to the sort. This cursor modifier, like the limit modifier, returns the cursor, and so in order to avoid eagerly printing out the results of this query, I'm going to tack on the null again. At this point, if I iterate through the result documents using this while loop, I should see my results in reverse order by name. And indeed, I get them in reverse order by name, remembering again that the sorting that we perform is lexicographic according to the byte encoding of the UTF-8 representation of these strings, which is to say, in effect, ASCII ordering. And finally, the integer is presented last. You can put these two things together, limit and sort, more or less in the way that you might expect. I'll establish a cursor again, and tack on both a sort and a limit. Let's say 3. Because these cursor modifiers, sort and limit, return the modified cursor, it's possible to chain them together in this fashion. And now if I step through the documents on this cursor, I should see them sorted in reverse lexicographical order, and I should only see 3 of them. And indeed, there they are. It's important to understand that the sort method and the limit method modify the information that's transmitted over to the database. I can't apply these methods to a cursor after having begun retrieving documents from the database, or even checking whether the cursor hasNext. This is because the sort and the limit need to actually be processed inside the database engine. They're not processed by ordering the documents in memory in the client. They're processed by server-side ordering and limiting. There's one more important method that you need to know about that modifies cursors, and that's called skip. Just like sort and limit, it modifies the cursor and returns the modified cursor. And so, if I set up a new cursor and tack on a sort and a limit and a skip, then the instructions are sent over to the database to retrieve documents from the people collection, ordered in reverse lexicographic order by name, skipping over the first 2 that are visited in that ordering, and showing me only 3 documents after the first 2 are skipped. And there we are, Fred, Edgar, Dave. It's important to understand that sort and limit and skip, which are quite analogous to the order by, limit, and skip in SQL, are processed in the same order. First the sort, then the skip, then the limit in the server. They're not processed in the client, despite the fact that the method calls appear to be modifying a client-side object. They're actually modifying the instructions that get sent over to the database. Okay, if you got all that, let's have a quiz. Remember the scores collection that we came up with before, having a student number, a type field, and a score value? Write a query that retrieves exam documents, that is to say, documents where the type is exam, sorted by score in descending order, skipping the first 50, and showing only the next 20 that occur after the first 50.